5.3 first, and then we'll do 7.1 after that. So let me go ahead and share my screen over here. Okay, so you should be able to see the screen. Now they're talking about graphing our system over here to see what the solution would be, but I think we'll just go ahead and solve this like a system of equations just using substitution or the addition method. Let's take a look at this first. Okay, so we are given y equals absolute value of 6 and y equals x plus 35. So if we are doing this instead of graphing, which method would you go with? Addition or substitution?
Let's do substitution.
Yeah, substitution would make more sense because your first equation is absolute value of 6. So we really wouldn't be able to use addition method over here. So you are basically going to use substitution, and you can substitute equation 1 into equation 2, which would basically mean you're going to end up setting these guys equal to each other. So you would have absolute value of x equals x plus 35. Now, since this is absolute value, remember we are talking about absolute value as being the distance of the number from 0. So you can get that same distance on the positive side, or you can get that same distance on the negative side. So anytime you are solving an absolute value equation, you set these as two separate equations. So we can take 6x equal to x plus 35 as the first setup, or we can set this up as 6x equals the negative of x plus 35. So let's start with the left-hand side. What happens when you try to get x by itself? What are we going to get as our answer? So of course, our first step would be combining the x terms. So I subtracted my x. So on the left-hand side, we will end up with 6x minus x, which of course gives you 5x. You're left with 35 on the right. So what are we going to get for our x value?
Then you divide by 5 and you'll get 7.
Yeah, very good. 5 will go into 35 7 times. Okay, so that's going to be from that left-hand side. Now what's going to happen on the right-hand side? Of course, the first thing would be to distribute that negative sign inside the parentheses, which will end up giving us negative x minus 35. So again, you would need to get your x on the same side. And 6x plus 1x, of course, gives you 7x equals negative 35. And what do you get for your x value here?
-5.
Very good. Yeah, Brittany. So you would divide both sides by 7, and then of course 7 would go into negative 35 -5 times. So we would actually end up getting two different x values from here. And then what will we do to find the y value?
You're going to plug in your -5 and your 7.
And which equation do we want to use here?
The y equals x plus 35, equation 2.
Okay, sure. And of course, you can use any of the two original equations, but let's go ahead and use the second one. So y equals x, oops, x plus 35. And what will be our two answers?
So for your first one, you'll have well, it'll be y equals 42. So then it'll be 7 and 42 as your,
Very good.
and then your other one is going to be y equals 30. So you'll have negative 5 and 30.
Alrighty. Okay, and then remember the easiest way to verify is that you have the right numbers is check using both these ordered pairs in both of your original equations. So just to show you a quick example here, let's use our first equation to a quick check. So if you do 6 times 7, that's of course going to give you 42, an absolute value of 42 is 42. So it will check out for the first one. For the second one, again, using the same equation, y is 30, and then you have 6 times negative 5, which would of course give you negative 30, but we know absolute value of 30 is going to be 30, so it's going to check for the second one also. And then of course, never a bad idea to check in both equations, so go ahead and check in the second equation and you should get the same result. So we've got 7 and 42, negative 5 and 30. Okay, so these are ordered pairs. And they're just asking us to use a comma to separate it. All right, there you go. And let me see, somebody just came in. Okay. Justin sent me x equals 7. Oh, okay, Justin, I just saw that. Yes, that is correct. So just looking at those two ordered pairs, I don't think I'll be able to make this bigger than this. Do you have any idea which graph might support this solution, A, B, or C?
A. Well, I don't know where. I can't tell where the x-axis is.
Oh, okay. Let me see if it will let me show you that. So it's kind of weird, but the bottom of your box is actually your x-axis.
Oh
In
yeah, so
part
A.
A. And then for part B, the top is the x-axis, and then the bottom is the x-axis again here in C.
Yeah, so A.
Okay. Does anybody else have a different answer than what Jacob has? So you can see that you have your equation, and that's right here in the top corner. Y equals basically a positive absolute value of 6x. So that does actually tell us that it should be your absolute value function opening up.
Right.
Second equation is y equals x plus 35. So that's a positive slope, which of course tells us our line should be going up. And so that automatically actually takes option B out of the place, and that's because your graph is opening down for that absolute value. For part C, you will actually see the straight line is going down, which means it's got a negative slope. And of course, that's not the case with our second line, y equals positive x plus 3y. So even just by using process of elimination, you can see A has to be our option. But if you look at where the 2 points are intersecting on these graphs, you can see this is at positive x value, and this point is higher than this one, which of course tells you your y value is 42 for that first ordered pair, and the y value is 30 for the second ordered pair. So that point on the right has to be higher than the point on the left. And then of course, the x value being negative 5, we know this point had to be towards the negative. x-axis. So again, you just using all of those, you can verify what your graph should be. So let's go ahead and clear all of this out. And we're looking at option A. All righty, very good. Did any of you have a question on this? Okay, so let's look at this guy over here. They're asking us to use the addition method to solve this guy. So let's see, we have 2x squared minus 4y squared equals -8. Our second equation is 5x squared plus 3y squared equals 32. Now they're asking us to use the addition method to solve this. In this case, you want to leave your variables as x squared and y squared and just think about, okay, do I want to eliminate x squared or do I want to eliminate y squared? So which one would you go with?
Let's eliminate y square.
Okay, we are eliminating y squared. So that means our coefficients have to be opposites of each other. Now, y squared was a good choice because you already have the positive and the negative sign. Now, what common number can we use here which would be divisible by both 4 and 3?
1.
No, because 1 would not be divisible by 4, right? Because you would end up with 1/4 or 1/3. So a
Oh,
number
okay.
that's large enough that can be divided by
12.
both 4 and 3.
Oh, gotcha. Yeah, 12.
Yeah, very good, Kate. Yeah, so that will be 12. So that means what do we need to multiply our first equation by to make that into a -12? The first equation.
By 3.
Very good. And the second equation?
By 4.
Yeah, very good, Levi. So we are going to be adding 3 times of equation 1 with 4 times of equation 2. Okay, so that will end up giving us 3 times 2 will be 6x squared minus 3 times 4, of course, is 12y squared equals, what's -8 times 3? Okay, -8 times 3 will give us what? All right, very
Negative
good.
24.
-24, Kate. All right, now tell me what our second equation will become after we multiply by 4.
$20x squared
Okay,
minus 48
say that one more time, please.
minus 48.
Where are you getting -48 from? Because all I got from you was 20.
Oh, sorry. Whoops. My bad. It's my bad.
Okay.
I multiplied in the wrong equation there for a second.
It's just going to
Okay.
be positive 12y.
Okay, yeah,
equal
looks
to
like I got an
128.
Yeah.
answer for Beatrice here. So yeah, positive 12y squared and then 32 times 4 is 128.
Yep.
Right, very good, Beatrice. So then, let's see, Alexander, okay. Now we're ready to add these two equations. So what do we get once we're done adding them to?
$26x squared.
Okay, 26x squared. The y terms, of course, cancel out. And then on the other side,
116.
128 minus 20.
Oh, 24. Sorry, I did. Hold on.
Yeah, very good, Levi and Beatrice. 104 looks good. And then what will you get when you want to isolate your x square?
Four.
Yeah, very good. So the first step is to get x squared by itself, which will... Okay, no problem, Alexander. I think you should be okay. We've just done one example. We're on our second one, okay? Alrighty, so 104 divided by 26 will give you 4. Now, of course, our ultimate goal is to get x by itself, which means we end up taking a square root on both sides, which will give us one positive, one negative root, and you get x equals plus or minus 2. So you're actually getting 2 answers. There we go. For x, and then 2. Sure why this guy is not writing. Okay, there we go. Find y. Now to find y, which equation do you guys want to use? First one, second one?
Let's use the first one.
First one, okay. 2x squared minus 4y squared minus 8. All right, so let's start with our first x value, x equals 2. So that would be 2 times 2 squared. That should be equals negative 8. 4y squared equals negative 8. So what will this portion give us when we simplify it? 2 times 2 squared. Yeah, very good, Beatrice. 2 times 2 is 4. 4 2s are 8. Minus 4y squared equals negative 8. Go ahead and move that guy to the other side. Our goal right now is to get y squared by itself. So on the right-hand side, you've got negative 8 minus 8, which will end up giving us negative 16. Divide both sides by negative 4. We get y squared equals 2 negatives will become positive, and then of course 16 divided by 4 will give us 4. Okay, and then of course to get y by itself, take a square root on both sides. And looks like we are also getting y equals positive and negative 2. Now remember, we originally started out with x equals positive 2. And with that, we are getting 2 values of y. So these will be the 2 ordered pairs that come out of this pair of your x value. So 2 and 2 negative 2. Now, if you guys have seen the video, then you should know that we are actually talking about here intersecting, which in this case, it looks like we are intersecting an ellipse, which would be a oval kind of shape. And it looks like we're actually intersecting it with a hyperbola, and these would be shapes we will be talking about in the next chapter. So when you're intersecting a ellipse with a hyperbola, as you will see, we are actually intersecting at 4 different points. So what's happening here, with one x value, you are getting 2 points. So you can basically think of these points being basically one on top of each other on the positive side. And now we have to find what kind of answers we get with the other x value we have. So we've used positive 2. Now let's go ahead and use x equals negative 2 and see what kind of y values we come up with from this one here. It's the same equation, but instead of positive 2, we are now using negative 2. All right, so again, can you tell me what this part here will come out to be? It would still be 8, yeah, because negative 2 squared, negative times negative will still end up becoming positive 4, and then positive 4 times 2 will still end up giving us 8. So essentially, you are going to see the same answer that we got from our other x value here, because your 8 was still positive. Move that 8 to the other side. You end up getting negative 16. Again, divide both sides by negative 4. And we end up getting y squared equals positive 4. Take a square root on both sides. And of course, you will end up getting y equals plus or minus 2. But this time, we were using our x value as negative 2. So you are looking at negative 2 and 2, and negative 2 and negative 2. So all 4 of these are going to make up our solution set for this system of equations. So we are looking at positive 2 and 2, positive 2, negative 2, and then negative 2, positive 2, negative 2, negative 2. All right, so let's go ahead and check this answer in here. So we've got positive 2 and 2, oops, no, what I wanted to do, there we go. Positive 2, negative 2, and then now we are using our x value as negative 2 with positive 2 and then negative 2 for both. Good question on this example here, guys. Especially for those of you who kind of came in a little bit late, did you have any questions on 5.3? No, okay. So is everybody okay with chapter 5 now? As you can see, I have really cut down on the homework for this section 5.3. So you are really only looking at these 2 examples that we looked at, and the others are, this one is just asking you to test and see if that is a solution to the system or not. And then you've got a couple vocabulary questions here. So is everybody okay on chapter 5? Okay. So just to remind you again, chapter 5 homework and exam and everything is due for Wednesday, which is the 29th at midnight. So yeah, I would say go ahead and use your time. Go ahead and do as much as you can, and then we'll do I guess a status check on Wednesday and see how you guys are doing with chapter 5 and if you need more time or not. But for now, we're just sticking to Wednesday's deadline, okay? If you haven't emailed me, please make sure you email me for your passwords for your chapter 5 exam. All right, so when we get into chapter 7, this is where we start talking about conic sections. And if you actually click on this image over here, it actually takes you to a YouTube video. And again, if you've seen the lecture, oops, if you have seen the lecture, then you've seen the video, but if not, it's a really good video about just how these conic sections are formed and how these shapes come out to be, okay? So basically, as you can see, we have these double right circular cones over here, and depending on how you intersect them with the plane, just think about a piece of paper, that's where we end up getting these different conic sections from. So we've got a parabola, a circle, an ellipse, and a hyperbola. Now basically your circle is just a special type of ellipse, because you can see for an ellipse, our plane is at an angle when it intersects the cone, whereas for our circle, we keep the plane perpendicular to that axis of the double circular cone. And so your circle, of course, is going to have a little bit of a different shape than the ellipse, which means we will have a little bit of a different equation for the ellipse as compared to the circle. Now, as I was saying before, you know, we are looking at this more in a geometric sense rather than algebra sense. So that's why we talk in terms of the focus and the directrix. So let's take a look at this image over here. So if you've got a parabola that opens up, you will see the focus is going to be above the directrix and your vertex is going to be in the middle. So basically one thing we need to remember is that this distance between the focus and the vertex is going to be the same distance, which is going to be between the vertex and the directrix. Now your directrix is going to be a line which is going to be a horizontal line when your parabola is opening up or down. And the focus is basically, again, going to be a point such that your axis of symmetry will cross or pass through the focus and the vertex, and it's going to be perpendicular to the directrix, which means that directrix and the axis of symmetry are going to be making a 90-degree angle, okay? Now, if it is a parabola that opens downward, kind of like the image on the right-hand side, then you will see our focus is going to be beneath our directrix, okay? So if it opens up, the focus is going to be above the directrix. And remember, when a parabola is opening up, that means our A value is positive, and that also means that our P value is positive, and P is that distance between the focus and the vertex, or P is the distance between the vertex and the directrix, okay? If your parabola is opening downward, that means your A value is negative, and that also means the distance P is also going to be negative, and that actually comes from this relationship between A and P variables right over here. So whatever is the sign on A is going to be the sign on P. So that's why it's crucial for us to know if our parabola is going to be opening up or down when we are looking at these examples over here. And then of course we know the ordered pair HK is the vertex of our parabola. So if you just take that value of K and add that distance of P, the ordered pair H comma K plus P gives you the focus of your parabola, and taking that K value again and subtracting the value of P from it. So the equation Y equals K minus P is the equation for the directrix. So remember, focus is a point, so that's why we use ordered pairs. Directrix is a line, so that's why you have an equation of a line for your directrix. And this is where we are using the transformation form of our parabola here, A times x minus h squared plus k. But if you were going to be using the standard form of your parabola, then remember to find the vertex, we use x equals negative b over 2a as our equation to help us find the x coordinate of the vertex, and then whatever answer you get, you put it back into the equation to find your y value. So that would be another way we would go about finding these values over here. So let's go ahead and see what kind of examples we have for your chapter 7 over here. Okay, so this is just vocabulary. Okay, this one here is asking us to use the graph. It's saying the graph shows the parabola along with its vertex, focus, and directrix. So they want to know what the coordinates of the vertex and focus and the equation of the directrix is going to be. So just by looking at this, can you tell me what the coordinates for the vertex of this parabola are going to be?
0, 1.
Alrighty, 0, 1. What will be the coordinates for the focus?
0, 2.
Okay, very good. That should be focus, 0, 2. And now for the directrix, what would that equation for that horizontal line be? It's right on top of the x-axis, right?
Yeah.
So what is the y value at the x-axis? Let me see, Alexander has y equals 0. That's correct, Alexander. Yeah, very good. So y equals 0 is going to be the equation for our directrix. All right, let's plug these answers in and let's see what they say. Oops. Do that. Okay. So they're asking us to put in our vertex, which was 0, 1 already. Focus is 0, 2. And the last one was our directrix, and that was y equals 0. There you go. Alrighty. So let's go ahead and clear all of this here. So again, this one you can see they're just asking you to use the graph. Same things happening here. They're saying graph to the right shows the parabola, vertex, its vertex, focus, and directrix, determine the coordinates and the equation. So this is the only question where you have to actually calculate and find your equation. Okay, so they are saying find the equation with the given focus at 0, 4 and the directrix at y equals -2. So let's go ahead and take a look at this guy over here. So this is for 7.1. We have focus at 0, 4 and directrix at y equals -2. Okay, so just to give us a rough idea where these values fall, you are looking at 0, 4, so that's going to be 1, 2, 3, 4. This right here is our focus, and then the directrix is at y equals -2. That's going to be the horizontal line. This is the directrix at y equals -2. Now we know, and let me go back to our graph over here. Now we know if the focus is above the directrix, that means our parabola is opening up, kind of like this left-hand side graph over here. So this actually tells us that our parabola opens up So this means our A value is going to be positive. And if A value is going to be positive, then that distance between the focus and the vertex, or the vertex and the directrix, is also going to be positive. That's your P variable. So to find the equation of the parabola, we need the A value, we need the H, and we need the K. The other thing that will help to remember is our focus is defined as H comma K plus P. Directrix is defined as Y equals K minus P. So focus is H comma K plus P. Oh, come on there. And then the directrix is Y equals K minus P. So you can use, as I had shown in the video, you can use the equations K plus P equals 4 and K minus P equals -2. So I'm just using this definition here and this definition here to basically come up with my system of equations. And in this case, you don't really have to do much because your P variable already has the opposite sign. So if you just add these two equations like we just did with our addition method, your P, of course, will cancel each other out. You add the K's, K plus K gives you 2K. 4 plus -2 will give you 2. And then just solving this equation will end up giving you your K value, which of course comes out to be 1. So that's this number right over here. Can anybody tell me what our H value is going to be? Because it's given to us. We don't have to find it.
Isn't it 0?
0.
It is 0 because it's the same X coordinate from your focus. So our H value is already going to be 0. So the H is 0. That means we only really need to find that A value to finish coming up with our equation. And for that A value, we need to use this relationship between A and P. A equals 1 divided by 4P. So let's go ahead and write that down. So what we're actually going to do is we're going to come back to our system of equations here on the right, and then using any one of these original K plus P, K minus P equations, we actually need to find out what our P value is going to be. We can use that first equation, K plus P equals 4. If K is 1, what is your P value? Okay, I've got an answer from Beatrice. That's 3. Very good, Beatrice. That's correct. Basically, you're just subtracting 1 and you end up getting P equals 3. So once you have that P value, you come back and calculate the A. And what will this A value come out to be?
One,
Go ahead.
1/12.
Yeah, very good. 1/12 because 4 times 3 will give you 12 on the denominator. Very good, Beatrice. So now that we have our A value also, you basically need to just clean up this equation and come up with your final answer. So that's Y equals 1/12. X minus 0 will of course just become X. So that's X squared plus 1. Or you can basically write it as Y equals 1/12 X squared plus 1. And this is going to be our equation. Before I actually go into our MyMathLab and type the answer, and there is one thing I wanted to talk about. To find what our p-value is, the other thing you could have done is this distance between the focus and the directrix. We know halfway between that is where our vertex has to be. So this is a total distance of 6 units. If you just start where your directrix is at, which is at -2, and just keep counting up till you get to the focus, that's going to be 1, 2, 3, 4, 5, 6. 6 places, oops, 6 divided by 2 would give you 3. So at the third marker, so that's going to be 1, 2, 3, right here is where you would have found your vertex at. So this vertex would have been at 0, 1. And of course, you can see that is what our H and K values were. And then you can see the distance between focus and vertex is 3 units. Distance between vertex and directrix is also 3 units. So you could have used that idea of just halfway between the focus and the directrix is going to be your vertex, and then using that you could have come up with your p-value also, and then work backwards to find your k. So just an idea, you don't have to do it this way, you can do it with this system of equations, just whatever you are comfortable with and makes more sense to you. Okay, so let's plug this answer into our question here. 1/12 x squared plus 1. Okay, there you go. So any question on this problem over here? So like I said, we have diminished your homework assignment, so you can see we're not putting that many questions in chapter 7, because at this point it's more about just introducing you to the conic sections and making sure you're at least able to look at some of the properties that come from the conic sections, and not get too much into detail. Again, guys, I would recommend you to go look at the video for 7.1, because I do talk about the reflective property that we are interested in that comes from conic section. So if you look at not this right here. So what happens in this case is if you have a light or a sound source somewhere over here, then those light rays or sound waves are actually going to come in the direction where you can see these arrows going. And it's going to bounce on that parabolic surface. And the reflective property of this parabola is such that it will bounce on this parabolic reflector, and then all of these light beams or sound waves, whatever they are going to actually concentrate right here at the focus. So, this is what the technology is used in telescopes. I think they have a bunch of different examples over here. Yeah, they're talking about how we use this to magnify the light coming from distant stars in telescopes. When you are talking about spotlights actually is going to reverse the process. So that means in a spotlight, your light source is actually going to be here at this point where the focus is. And that means your light will actually go in the reverse direction from the light source. It's going to bounce on that parabolic reflector, and then that light is actually going to go out. And of course, we use spotlights to basically shine in on a particular object or, whatever we are focusing on. So that's kind of how the idea of spotlights work. And they're talking about this reflective property is used in telephoto camera lenses, radio antenna, satellite dishes that we use, even something on your cable television, eavesdropping devices, and even something as simple as your everyday flashlight. So that's kind of the idea of where this reflective property of a parabola comes into play. And that's kind of why we are interested in this whole concept of the focus and the directrix, And then you have this really neat example where we are talking about the Hale telescope and how they came up with that equation of the parabola for that mirror, which you can see in the red over here. What was the equation of this parabolic mirror so that, you know, we could get this Hale telescope to work. So again, please make sure you look through the video for 7.1. All right, so I want to come back and talk to Brittany. So Brittany, when we looked through we didn't really look at 4, but we looked at question 3. Did that answer your question about how to come up with the directrix, or did you want to look at specifically for number 4?
I think I might be able to figure it out, but if you just don't mind going through it just so I could make sure, that'd be nice.
Yeah, we can do that. Let's make this guy bigger. There we go. So can you tell me, and this is open to everybody, what is the coordinates for our vertex for this parabola?
One and 4.
1 and 4, okay. Coordinates for our focus?
1 and 3.5.
Look again. Because this was the 1, 2, 3, 4, 5, and then 6.
Yeah, I feel like it would still be 1 and 3.5. So unless someone else.
No, think about it. 3.5 would be here. It's between 3 and 4, right?
But isn't that what you're wanting? Is that point right there underneath your vertex?
Oh, that's right, because I am looking at the directrix over here. So, sorry, yes, Brittany, you are right. The focus would be at 1. And I don't know if they're going to accept decimal answers. Do you know if they accept decimal?
Yeah, they were.
Okay. All right, so we can leave it at that. So sorry, yeah, you were right. The focus here is at 1 and 3.5. Okay, so what will be the directrix then?
So this is where I was getting confused. So you're saying that I'd have to figure out my P, so I could do K minus P, and then that's how I would figure it
Not
out?
in this case, since they're actually showing you where the line is for your directrix. So what is this Y value right here, where your line is crossing the Y-axis at?
4.5.
4.5, yeah. So that's going to be your equation. And if they're accepting decimal answers, then you should be okay with this. That is correct, Levi. Yeah, they did use this idea for the Hubble Space Telescope, but the manufacturers, when they were actually making the mirror, which was the parabolic mirror, they had a slight miscalculation in their process. And so when this Hubble Space Telescope ended up in space, the first few images were so blurry that you know, obviously this whole big huge $1 million project was not successful, so they had to send astronauts back into space and install a second mirror which would adjust that error they made. And of course now we have amazing images coming from Hubble, but you know, he's getting ready to retire soon. All right, so we've got our vertex as 1, and 4, and then our focus is at 1 and 3.5. Okay, good to know they are accepting decimal. So let's see. Now remember, your parabola is opening up and down, which means your directrix is going to be a horizontal line, and all horizontal lines have the equation of y equals, let me go ahead and clear this out. Okay, y equals, so you will have to select the y variable there, and then this guy should be 4.5, and there you go. So that's all you really needed, Brittany. You don't need a calculation for this. You just have to figure out what those coordinates are and where your line is crossing the y-axis at.
Okay, thank you. I was just making it harder, I guess, than what it needed to be.
Yeah, because like I said, the only, where did you go? There you are. The only calculation you are going to have in this homework is this last problem that we looked at.
Okay, thank you.
Yeah, you're welcome. Okay, what about the rest of you? Did you guys have any questions on chapter 5 or chapter 7? No, not right now. Okay, Alexander, not a problem. So just to kind of give you, I guess, a heads up on what this week and next week is going to look like. So we will finish talking about 7.2 and 7.3 on Wednesday. I actually didn't realize it would only take us less than half a class to go through both 5.3 and 7.1. So we'll go ahead and finish 7.2, 7.3 on Wednesday. For next Monday, which would technically have been our day of taking the final exam, we're going to use that Monday's lecture as review for the final. And then you guys will have Monday and Tuesday to take your final exam. So for the final exam, it will not be, open as long as our chapter exams or our chapter homework has been. Since this is the final exam, we can only administer it to you for a day or 2 days at the maximum. So we're going to be doing, I'll leave it open Monday and Tuesday for you so you can take the final anytime during those 2 days. Same thing, it will be password protected, it will be timed. So just make sure you are sending me your password request in good time and not waiting till the last minute, because some of you will realize who sent me an email over the weekend, you did not get a reply as quickly as possible. So just don't wait till the last minute to request for your passwords. Your final exam is going to be a little bit more strict in terms of just what questions we can ask on it and that kind of thing, because we are a little bit more lenient on the chapter exams, but of course we have to maintain the integrity of what a final exam is, so we cannot be as lenient with the final as we have been with the chapter exams. Okay, Beatrice wants to know how many questions are on it. Beatrice, normally I have 30 questions on the final exam, and I'm going to try and keep it at 30, but I will have to modify some questions because, normally I actually print and type my own questions for the final exam, but since we are having to do this on my math lab, I'm going to have to modify some of your homework questions to maybe accommodate what our final looks like. So I am actually still working through those questions. Levi, it will have a time limit. And since our class is 1 hour, 40 minutes, I'm probably going to keep our time limit at that same time limit as class time. I will actually work through the final myself just to make sure that is enough time for all of you. So if I feel like you need more time, then I'll make it longer than 1 hour, 40 minutes. But right now, we're going to keep it at 1 hour, 40. You are fine, Levi. Please don't worry about it. Any other questions you guys have about the final or just in general as we are getting to the end of the semester here?
Will there be any of like the vocabulary questions on there?
Not on the final, no. I do have one, well, I don't know if I will be able to transfer it to my math lab, but I usually try to do a match the following kind of question where I give you the equations and I ask you to write down what type of equations they are. Are they a straight line with a positive slope? Are they a straight line with a negative slope? Are they an equation of a circle or a parabola? You know, that kind of thing. But like I said, I still need to see if that is a question I can bring to my math lab or not, because I haven't seen anything like that in my math lab. So yeah, some of these are going to be an interesting changeover, but just as far as vocabulary questions like the fill in the blanks kind of thing, you will not have those.
Okay, thank you.
Any other questions popping up in your mind about the final, or just as we are coming to an end?
Not that we can think of.
You guys are good for now?
I think so.
Okay. Yeah, and you know, anything, of course, we've got this whole week, we've got at least half of next week. Anything that comes to mind, just kind of let me know. If you need extra help with anything, let me know that as well. So like I said, we'll finish 7.2 and 7.3 on Wednesday. You guys have till Wednesday midnight to finish your chapter 5 assignment. So if you haven't sent me a request for the password, go ahead and do that between today and tomorrow, so that way you're not waiting till Wednesday for the request, guys. And then we'll definitely answer any more questions you guys have on Wednesday, okay? So that's it for today. I thought this would take us a lot longer than it did. So that's all we have planned for today, guys. If you have no more questions, you are good to go.
Cool. Thank you.
Great day, guys. Thank you. Take care. Stay safe. Bye. Thank you. Bye.
Bye.
Yeah, bye-bye.
Thank you,
Bye,
Miss.
Kate. Take care. Bye-bye. Thank you, Levi. Bye, guys. Yeah.
All right, I have one question before I go.
Okay, yeah, sure.
Is it possible before the final exam, is it okay if I work a couple problems, but with you before the exam from chapter 1?
Yeah. When did you want to do that?
Probably after I get the chapter 7 done.
So are you thinking kind of like maybe later this week, or maybe even Monday of next week?
Yeah, possibly that around that time, yeah.
Okay, yeah, definitely. Just kind of keep me updated and let me know exactly which day you would like to meet, and I'll set up an appointment for us like I've done in the past.
Mm-hmm. Because I'm trying, because with this final exam, I'm trying to go past the exams that I failed. There's only like 2 that okay, 1 is a D, which isn't that bad of a grade like the chapter 1 exam.
Okay. Yeah, so we can do that. We can go over the questions you want to go over, because obviously chapter 1 is also going to be part of the final. And the other thing, Justin, I would recommend is, you will see I have opened a practice final exam. It's called the comprehensive practice final exam. So look through that also and see the type of questions that are in there, because that will also help you study for the final, okay?
Okay.
Yeah, so let me know, like I said, what day you want to meet, and we'll get together and go over any questions you have.
Okay, I will do that.
All right, no problem. You take care.
You too.
Yeah, take care. Bye-bye.
Bye.